Alright, we're going to do everything this says. Let's start off by, alright, we'll restrict the domain so it has an inverse. Let's go ahead and graph this guy first. So this would graph as, this would graph equals 1/2 x squared, right? I'm just going to plug in a few points to give us an idea, right? So your x and this your f of x. Alright, if I plugged in 0, 0 squared times 1/2 is 0. If I plug in 1 or -1, both 1 and -1 squared is 1, times 1/2 is 1/2. Let's go ahead and get one more point. Let's plug in 2 and -2. We can kind of see our vertex already is at that 0. Both 2 and -2 squared are 4, and 1/2 of that is 2. So let's plot those. All right, we got, well, what I can plot anyway. So we got our 0, 0. We've got -1 right there. We've got our 2 at 2. And I can kind of see it going this way. We reach the end of the graph, and we're kind of going up like that. Alright, so it's pretty obvious we're going to restrict our domain. So given the function, restrict the domain so that it has an inverse. And I can kind of see that there's repetitions on each side if I restrict the domain. So we're going to make sure that it's a one-to-one function. So if I'm going to restrict the domain so it's a one-to-one function, looks like my option is I can't have any of this over here because it's not a one-to-one function. I have to restrict it from 0 up. So my domain is going to be restricted. So let's do it. We'll restrict the x. We'll say x is greater than or equal to 0. And you're going to notice we're always going to do this right here. We're going to do it at the vertex of these graphs. Alright, so let's find the inverse. So remember how to find the inverse. Rewrite it as y equals 1/2 x squared. We're plugging in y in for that. And we switch, right? We take the y and x and switch them. Now we're going to solve for y. We're going to multiply both sides by 2, which gives us 2x equals y squared, and we take the square root. Now I would say positive or negative, but we have now just said that, hey, you know what? We're not allowed to have a negative, so we're going to keep it positive, and let's write that as f inverse of x equals, let's put that x there, the square root of 2x. So I could plug some more points in there. Let's just plug in a couple points to graph so we can kind of see the trend. 0 is easy to see. If I plug in 0, 2 times 0, 0 squared is 0, 0. You know what else would be easy to plug in? 2, right? Because 2 times 2 is 4, square root of 4 is 2. If I plug in 0 and 2, I can see this, and I'm going to let you know that it's going to graph like that. So this would be f inverse of x. Alright? So if you don't remember, inverses are reflections over y equals x, and we can kind of see that happening, right? This would flip to here, this would flip to here, and we can graph it and test it. And there's one other things we can do, because here's how you're really supposed to test to see if they're inverses, right? We found the inverse, and we're confirm it with composition, right? So here's composition. Composition is when you take your f of x and you plug in f inverse of x into that equation. That's a composition of functions. So this says take this function and write it without the x. So I'm going to say 1/2 without the x is a parenthesis, right? I've written everything I see here without the x. And now I'm going to plug the inverse function in. So I'm going to plug in this. I'm going to plug in the square root of 2x. And if by the time we're done, all we get is x, it is in fact an inverse. So let's do this. So I say 1/2 of n squares, and square roots cancel each other out. So 1/2 of 2x. And then 1/2 times 2 is just x, and we've checked it. It's an inverse function. So we've done everything we had to do on there. Alright, so notice that a square root function, right here, is in fact the inverse of a squared function. And we're going to keep going. And do one more. Here we go. I did a quick table of values, and there's a lot of them we could do here. So we'll say x and f of x. Let's plug in a few points. I'm going to start in the middle with 0 so you can kind of see the vertex on there. If I plug in 0, 0 squared is 0 minus 7 is negative 7. If I plug in 1 or negative 1, negative 1 squared is 1, 1 squared is 1, minus 6 is negative 6. If I plug in 2, let's do 2 up here, or negative 2, right? 2 squared is 4 minus 7 is negative 3. Negative 2 squared is 4 minus 7 is negative 3. So this would give us that table. Let's go ahead and plot. If you also just want to see that that's k right there, that's really just dropping us down 7. And we are getting something that looks like 2 is negative 3. What if I plugged in 3? 3 is going to give me 2. That's probably good enough on that side. And on the opposite side, just kind of matching these up. I'm going to get something that looks like this on the opposite side. And we need to restrict the domain. Well, let's restrict it right here. The domain again is 0, so if I restrict the domain, I'll write the domain. Domain at f(x) is going to be x is greater than or equal to 0 again, because my graph hasn't slid. My vertex still has an x value of 0. In fact, it has 0, negative 7, doesn't it? Alright, so here we go. We're going to go and find the inverse. I'm going to do it over here. I'm going to say y equals x squared minus 7. We switch x and y. X equals y squared minus 7. We add 7 plus 7. We get x plus 7 equals y squared. Square root. And I get y equals the square root of x plus 7, or we could say the f inverse of x. Just saying that that's the inverse, equals the square root of x plus 7. Alright, we're going to test it, but let's do a table of values first. Most often when I see this, I try to plug in something, right, that would make this 0. So I'm going to go to the middle in here somewhere, plot a few points. I'm going to plug in negative 7. Because negative 7 plus 7 is 0, square root of 0 is 0. And if I go one higher, negative 6 and negative 8. Right? Negative 6 gives me 1. Uh-oh. Square root of 1 is 1. I can't do negative 8, can I? I get a negative number. That's right. We have restricted the domain. So let me erase this. Alright. Let's go up to, I don't know, let's do... I'm going to skip up a little bit because I realize if I plug in a negative 4, I'm anticipating what that answer would be. Let's do a negative 3. Negative 3 plus 7 is 4. Square root of 4 is 2. So let's stop there. Alright, that should give us enough. So we got negative 3 right here, 2. Oh, look, they're touching there. Alright. We have negative 6, 1. We have negative, negative 6 1's right there. Negative 7, 0. Alright, we can probably plug in one more. You know what? Since I know square roots, let's find something that would give me a perfect square. Like 2 would give me a perfect square, right? 2 plus 7 is 9. Square root of 9 is 3. So I can go to 2, 3. Let's go ahead and plot this, and we'll show you what just happened, right? Just plotting in points. Once again, I can kind of just eyeball it by checking to see if it is a reflection over y equals x, which looks a little bit like this. And we can see that it is. This came over here, and this up there came down there. And there's one other way to test it, all right? We can test inverses by doing compositions. So I'm going to say the f of f inverse of x. Once again, I plug in this without this, so I'm going to leave the x out and say blank squared minus 7. And within that, I'm going to plug in the f inverse, which is going to be the square root of x plus 7. These guys cancel out, which gives me x plus 7 minus 7, which these 7's cancel out and give me just an x. So the f inverse of x, let's go out this way, f of f inverse of x is x. So it works out. They're in fact inverses. Alright. Now, I'm going to stop. I would like you to try this without me. Same thing we just did. Plug in some points and plot it. Right? Find your inverse. check your inverse decompositions, and plot your inverse. All right. You should notice that it would be a reflection over this line. Page 2 done. All right, I'll keep going. You guys have an awesome, awesome, awesome day.